All right. The last in the series will be Pythagorean theorem with radical answers, but before we get there, let's go over some concepts, okay? You all should be familiar with this idea. 3 squared, as it's called, is equal to 3 times 3, which is 9, okay? So, we also know that this thing asks what number times itself, so this would be 3. The squaring goes from here to here. Squaring is this symbol right here. The square root symbol brings us backwards, okay? So the new question is, what happens if we have both of them at the same time? So I have this. Well, you can do one after the other, or you can go like this. And this goes back to 3 again. But basically, these two cancel each other out. This thing and this thing, they cancel each other out. And go straight here. We can also write it like this, though. It can be square root of 3. We don't know what this number is. It's not on this list. 3 isn't here. So if I plug in the calculator, it can give us something similar. So let's take a look. On the calculator, I'm going to type in square root of 3. It's 1.7 something, which is a really weird number, right? But we don't know it. But if we squared it, we can just say that these cancel each other out. We can just say this equals 3, okay? So for some more examples, if you square whatever this is just 7, this is just 3. This is 37, okay? Whatever the square root, as this little check mark thing is called, if you square whatever number is within that, you just get the number itself. Okay, the second part is, what if you have both a normal number and the square root number combined, and you're squaring this, okay? Well, first you square the inside number. And you multiply it by the outside number squared, or the one next to it. So this is 4 times 3 equals 12. So this itself will be 12. Okay, let's try another one to verify the process. So I'm going to try 4 and 2. This becomes 4 squared. This becomes rad 2 squared. So it becomes 16 times 4. No, not 4. My bad. 16 times 2, which gives me 32. Okay, so this is 32. I'll do one last example. I'm going to do 3 rad 5 squared. This becomes 9. 3 times 3. This becomes 5. So this is equal to 45. Okay? Hopefully you're familiar with these now. Let's continue to our assignment. All right, so just to refresh our memory, our equation is a squared where this time our hypotenuse is c here, okay? That is our variable that we're solving. So I plug in these two, 9 squared plus rad 19 squared equals c squared. And as we just went over, this will just be 19. This will be 9 times 9, which is 81. I add these two, I get 100 equals c squared. C is going to be square root of 100. But we see 100 is here, the square root is just 10. So our answer is 10. If you need more time, take a look at this, pause it, take a look at it for yourself. I'm going to continue. Okay. Next problem. Let's continue. So we have this is a leg, so let's call this one B. So this is 6 squared. And it doesn't matter whether you put A or B, as long as these are the legs and your 9 is the hypotenuse, okay? Let's multiply it. 36 plus B squared equals 81. B squared equals 81 minus 36. So remember, I subtract 36. And I get, that's 545, okay? So before we plug this in the calculator, this time if we read the problem, it says simplest radical form, okay? So to simplify it, we have to do, so first b is equal to square root 45. To simplify it, we have to divide by one of these numbers, like we did in one of the very first one, which is simplifying radicals. Find that we can divide by random numbers until we find something we can divide by. So 2, 3, no, 4, oops, 4, 5 happens to work, and 9 is also a number there, right? We can split this into 9 and 5. Then 9 becomes the 3. So you put 3 rad 5. This is your final answer, okay? This is simplest radical form. 3 rad 5. Once again, digest it a bit, take it in before we move on. Okay, let's continue. All right, let's go over one more of these where I have to do simplest radical form, and let's also look for the last type of problem they'll give you. All right, this is the last type of problem they'll give you, where you have this thing this time. So let's plug in 6 squared plus, or this time let's call this one A. So it can be A squared. Remember, it doesn't matter which one's A or B. Equals 2 rad 34 squared, okay? So once again, we multiply it, plus 36 equals, this becomes 2 times 2 times 34. Or let me do it on the side. 2 rad 34 squared becomes 4 times 34 equals 16,136. Okay, and then I subtract 36. I get A squared equals 100. So A equals square root of 100, which once again gives me 10. Okay, so the main part for this problem is knowing how to do this, where 2 times 2 is 4 times 34. Give me 136, okay? So this answer is 10. Okay. Let's look for the last type of problem, the second type of problem, so we can do it again, okay? These are all not what I'm looking for. All right, this is the type of problem I'm looking for. So I set up my equation. I have, these are the legs. This is hypotenuse, so 2 squared plus 5 squared equals c squared. 4 plus 25 equals c squared. 29 equals c squared, okay? So I'm going to try dividing by some numbers. 29 divided by 2 doesn't work. Divide by 3, no. 4, 5, 6, 7, 8, 9. So I've divided by all these numbers. It doesn't work. Sometimes the answer is just square root of 29. Since you have 2 tries, you can always try this one first if you're unsure. But if all else fails, you can't simplify it at all. This is the simplest form, okay? And that's it. All right, hopefully this helps you complete this. Like and subscribe. I'll see you next time.